So we're saying that the real objective, we realized not only did we want to achieve these performance objectives, but furthermore, this would entail the development of a custom dictionary and related techniques that go hand in hand with that to characterize the data. Okay? The key uncertainty then. So once we create the triangle, we can have as many, the square, we can have as many triangles or uncertainties related to that. But what I really want to find out is within the uncertainty itself, which is how do we develop the method to exploit the non-uniform data, we're saying, and compress and uncompress the blocks. The key issues or variables within that, I would say, are methods to characterize non-uniform data, optimal use of a compression dictionary. So they say we have to develop a compression dictionary, and then we have to determine how to deploy it. The definition and construction of the related data blocks, and how to minimize CPU utilization. So I'm saying those are the key variables, all of which are technology variables that the computer scientist would deal with. Not, will clients find this data useful, stuff like that as an uncertainty. Those are business problems. We want problems that would be faced by someone in information technology or computer science. The first of the activities then, develop a generic data model. We're told they looked at 10 alternatives, identified the most common frequency values, and evaluated the use of column valuing frequencies to create the prototype compression dictionary. Okay? And they told us we're using a relational database environment as opposed to sequential or any of the other database environments. So again, some of the decisions that we make that may have upstream or downstream effects. Okay? We don't have any results as a result of this because we're just basically setting up the first stage. But we found that a data model could be created, and basically the conclusion was the model proved feasible, develop a table-wide list of the most frequent values. Okay? That just allows us to go to the next stage. The next activity that the CRA provides is actual development of the compression methods. Here we're told they do 10 different samples. They test scripts, compare CPU utilization, integrity of data, and the method that they use: parallel load, delete update operations, full table scan, access by row. That will give us some feeling of how much time and effort we spend. Within our system itself, you can upload your documentation, you can allocate labor hours for contractors and employees, and you can allocate costs for equipment and materials as well. So the person who writes this would ideally make those cost allocations, and what I call that is having the technology drive the claim, letting the person who did the research tell you what they think the cost is, rather than have accounting tell you, well, here's how much we got in the project code, make it all fit, okay? Which is the reverse way to do these, in my opinion. Okay? Again, on this one we have no resulting performance, but we determined it's best to restrict the query refresh options to compress blocks versus entire tables. Again, good technological advancement there. We didn't know at the start. That's a conclusion that was not readily apparent to us. Okay, the big activity here is the development of the compression algorithm with dynamic techniques. So we've developed the data model, and we've developed the compression methods, including the dictionary and then methods to use it, and now we're putting those two together. We're starting to integrate those two ideas or components. So what we've done here is we've developed actual physical prototypes. We've done 3 samples using the buffer cache to organize and control the compression dictionaries. Okay? When calls are made to uncompress multiple blocks. So they've experimented. How do we define the blocks? How do we segment the blocks? How do we call the blocks? How do we query them? What differences would that make? We're told that of those 3 prototype compression algorithms, we did various revisions. Let's say 12 revisions to them. So often we do the prototypes, we don't nail it, we revise the prototypes 7, 8, 12, 15 times. Okay? That again will give the CRA ideas of how did you really spend 700 man hours here? Oh, I understand. You did 3 prototypes and revisions to them. And the people who review this are familiar with the kind of work that you do usually, so they'll be able to smell whether something looks reasonable or out of whack. Okay? So they looked at the compression techniques for data set changes. Each had to verify data integrity and various performance measures. At the end of this is where we start to get our first results. We're saying, as a result of putting these two together, we reduced CPU utilization to 70%, to 66% versus our objective of 70. So we exceeded our objective by 16%. We're at 116% of objective. Pretty close. I'm saying, well, that sounds like you kind of thought, it worked out like you thought. Great. Response time. Again, we want to go from 60 to 15, and we got to 22. So we didn't quite achieve it, but we're pretty close. 84% of objective. But maybe data compression, we wanted to go 3 times better, 5 to 15, and we got 131. Okay? So we exceeded expectation by 1,260%. And what I'm saying is when things like that happen, that's indicative to me that something unexpected happened. And we want to show the unexpected. What did we not know at the start? So I would come back and say to the person writing this, hey, can you explain, what is it? You don't have to be right. can you give me a hypothesis on why you think this could possibly have happened? Because even a guess, a hypothesis to try to determine how something worked could be a technological advance. They want to see you trying to explain why things are working the way they are. And I'm saying the best ones are ones that really vary from initial expectations, because there's strong evidence that if you're qualified to do that work and you see something very unexpected, that there was a technological advance made there. Okay? Any questions on that? Okay. Yes? Again, you do not have to reveal any proprietary stuff. I have clients that are so paranoid that say, Dave, even if I talk about the stuff that didn't work, a really smart guy might extrapolate where I'm going. And they're right. And I say, okay, well, Joe, you're right on that. The law gives you up to 18 months from your year end to submit if you're really paranoid. So by the time the guy gets it, it's 2-year-old data. And I actually have clients who do that on purpose for exactly that reason. That is how paranoid they are of their data and their information. So there are methods you could take, but ultimately, you're right. You're going to have to reveal something at the end of the day. Okay? And I have clients who are so paranoid that they will not even file claims as a result of that, especially on certain projects. They may file on some, and others they just say, you know what? Nobody gets to see this. End of story. Okay? So the conclusion is the discovery that we could use column value frequencies of initial tables to create an effective block-based compression dictionary. They also concluded that use of the buffer cache proof successful resulted in reduced response times, 80% when uncompressing multiple blocks. So these are things that you didn't know at the start that you learned as a result of the experimentation that the counter-revenue you see in this example says represents a technological advancement in the field of computer science or information technology. The end here? We're told that now we want to take this. And this is where I'm saying maybe the project ended here. I have some issues when you look at the original objective. They're saying now that we got this project successful after activity 3, we had an idea that we'll hire an external consultant and try to implement some of these compression methods to backup and recovery operations. And they found that it was actually successful, and the success was attributed primarily to compression dictionary rather than the data blocks, which they didn't expect. So again, technological conclusion or advance there. My one issue is this may be a new project. The CRA does not like what they just did here. Here's my objectives, here's what I'm going to do. I was successful at the end of activity 3, and now I'm trying to do new things with that. I'm saying this would probably be eligible work, but I would recommend that when you close the objectives of the original project, those objectives are closed. You can create as many new projects as you want. This, in my view, would be a new project. We took the results of the other one. This really wasn't talked about in the initial objectives. I don't like to tack those activities on at the end, because heaven forbid you're past 18 months, you may lose that activity. And now you do not have the right to resubmit. Okay? Thing flow through every activity. I'm saying, in this activity, did you have a result on any of them? No. This activity did not give us a result on any of the 3 objectives, right? What I'm saying is if you look at the original objective in the CRA, they said that they were applying to a data warehouse environment, right? Now they're saying now we're applying it to backup procedures. They didn't say anything about backup procedures in the objective. It's good that they did this, and I'm not saying the work's not eligible. I'm saying the way they disclosed it is not in form with the original objective, and I have seen this become an issue, that they will argue this is a new project. It has to stand on its own. Square, triangle, circle, not merely as an activity where it's just conclusions. Okay? I'm not saying it's wrong or that it might not go through, but I would caution you that you want to be careful on those kinds of things, because certain reviewers do take that very seriously. Okay? Lastly, correlation of compression block size with initial data set. So we look at 22 alternatives to implement the prototype to determine whether or not an optimal data table compression block size could be determined both on the basis of the initial data set analysis and the dynamic analysis. So it's kind of what we stated at the start. Can we now make a correlation or a formula or algorithm or some predictive thing that we couldn't before? And basically, what they say is we could not correlate the compression block size with either of those initial data size or dynamic analysis. We proved that we couldn't get the correlation we were hoping for. Despite our studies, that activity was a failure. But in the CRA's directives, they say proving a hypothesis incorrect can often represent a technological advance, as it would in this particular case. Okay, what my program would then do is allow you to print this all out on a single sheet. So if we want to look at that, as one page, and this is how we review it. What did we do to benchmark the data? Yeah, we did lots of stuff. Do we have quantifiable objectives? Do we have key variables of uncertainty? And then for each of the activities, how many alternatives did we look at? Did we get results on any of them? And where? And then which of the variables did we conclude on? If I see an activity conclude on at least one variable, that's a technological advance. If I see an activity that did not allow me any conclusions, then there's an issue. How does this fit into the whole? Okay? Maybe this is routine stuff. Maybe this is part of the business project, but not the SR&ED project, would be the way the CRA might look at that. Okay? And lastly, what I want to look at is how many hours or contractor dollars do I have in relation to each activity, and based on what I've done here, does that look reasonable? Okay? For each of the fiscal years in question. So what we can typically do on a review basis is look at each project in a snapshot like that and say, oh, good, good, good. Oh, let's look at this one a little further because it looks a little funny, and maybe we need more details.